Alright, in this video we're going to take a look at how an example of finding both the unit normal vector and the binormal vector for a given vector. We talked about in class how both of these vectors are derived, and you can see them in the two boxes here. I gave you those formulas, but we didn't get a chance to do an example. So we're going to go ahead and cover the example in your notes. It says find the unit normal and binormal vectors for the vector t, 3 sine t, and 3 cosine t. So we're going to consider this to be our vector r of t, or our vector function. And I would like to add one thing to this problem. I'd like to say not only find those vectors, but find those vectors at a specific point. Specifically, let's consider the point 0, 0, 3. So 0, 0, 3. Alright, so one of the first things we need to do is, because vectors functions are typically in terms of some parameter t, we need to go ahead and figure out the t that corresponds to the point 0, 0, 3. And this is easy enough. I mean, right off the bat, if you just look at the x component of this vector function, you can see that x equals t, right? X equals t. And then you can see right here, though, that x should be 0. So that right there says that t equals 0. Because 0 is what we know x to be, and x and t are the same. And you can verify that that works for the y and the z components of your vector function. If you were to plug t equals 0 into 3 sine t, 3 times the sine of 0 is 0, and also 3 times the cosine of 0 is 3. So t equals 0 gives us the point 0, 0, 3. So now that we've done that, we can go ahead and compute some of the things that we are going to need to find both my unit normal vector and my binormal vector. You'll notice the formula for the unit normal vector requires us to have t prime, but before we can have t prime, we have to have t. So if you remember, the way we find t is the following formula. That t is the unit tangent vector. So we already know that r prime is the tangent vector, r prime. So then to find the unit tangent vector, we take r prime and we divide it by the magnitude of r prime. So this is what we want to start off by finding. We want to find first r prime. So r prime of t, if we take this to be r prime is going to be 1, 3 cosine t, and minus 3 sine t. And since we want to find all these things at 0, it would be beneficial to know what r prime of 0 is as well. So we could go ahead and take a look at r prime of 0. If we plug in 0, we get the vector 1, 3, and 0. And we could also take a look at the magnitude of that. The magnitude of r prime of 0 is the square root of 1 squared plus 3 squared plus 0 squared, which is the square root of 10. Right? So we could then, for example, say that t of 0, if I was asking you for this problem doesn't ask for it, but we now have enough information to know that t of 0, or the unit tangent vector at t equals 0, would be the vector 1 over root 10, 3 over root 10, and 0. That would be the unit tangent vector at 0. We're not actually looking for that. You may have one in your homework, though, where you need to find that, so we'll give you that one for free. What we want is, again, reminder, we want t prime. So we need to take my r prime over its magnitude. So let's go ahead and take the magnitude of this. Magnitude of r prime of t is the square root of 1 squared plus 3 cosine squared, which is 9 cosine squared t, and negative 3 sine squared, which is again 9 sine squared t. This is the square root of 1 plus 9 times cosine squared plus sine squared, which is a nice result as far as simplifying goes, because we know that this right here equals 1. So you can see that this just becomes the square root of 1 plus 9, which we know is the square root of 10, which happens to be, so it turns out that the magnitude of r prime is always square root 10. We already found that at 0 is square root 10, but for every t it turns out that we have square root 10. So we now have enough information to find a general unit tangent vector. So in general, t of t is going to be right here. We're going to come back here. It's going to be r prime over the magnitude of r prime. So it's 1, 3 cosine t, negative 3 sine t, divided by square root of 10, which if we throw that magnitude into the vector, it's 1 over root 10, 3 cosine t over root 10, and negative 3 sine t over root 10. Now that we have t, we need to know what t prime is. So, because t prime is what we use to find n, the n vector, or the unit normal vector. So t prime now, we just take the derivative of this vector we just found here. And t prime then, since the x component is a constant, its derivative is going to be 0. The y component is cosine. We know the derivative of that is negative sine, so this is going to turn into negative 3 sine t over root 10. And then for the z component, the derivative of sine is cosine. So this is going to be negative 3 cosine t over root 10. And we want to evaluate this at t equals 0. So t prime of 0 is equal to 0. Of course, sine of 0 is 0, so that's 0 for the y component. And then, oh, I see I made a typo here. This is not square root t, that is square root 10. So again, if I plug in 0 for the z component, cosine of 0 is 1, so I have negative 3 times 1 over root 10, which is negative 3 over the square root of 10. And the magnitude of that vector, so the magnitude of t of 0, of t prime at 0, is the square root of 0 squared plus 0 squared plus negative 3 root 10 squared, which obviously is 3 over root 10. So we're now at the place where we can find the unit normal vector, because in your notes we saw that the unit normal vector n of t is equal to t prime over the magnitude of t prime, which we have. We just found it. So this tells us that the unit normal vector at 0 is that vector at 0, which we just found right here, 0, 0, negative 3 over root 10, divided by its magnitude, which is 3 over root 10, which is an easy calculation. This is the vector 0, 0, negative 1. So that would right there, highlighted in yellow, that's the unit normal vector at t equals 0. Okay, we could also go ahead and calculate this for the, we could calculate the binormal vector at 2, and that's just a simple cross product. We want to calculate that at t equals 0, so b at 0 is t at 0 crossed with n at 0. And going back to what we did earlier in the semester, we take this determinant to go ahead and find the cross product. We already found t of 0. If you scroll up a little bit, t of 0 is right here. No, I guess we did need that. I said it was for free, but we did need it. It's the 1 over root 10, 3 over root 10, and 0. So let's go ahead and write that in the second row of this matrix. It's 1 over root 10, 3 over root 10, and 0. And then n of 0 we just found. That was the 0, 0, negative 1. And if we go ahead and take that determinant, the first thing we see is that we get I times negative 3 root 10 minus 0 minus j times negative 1 over root 10 minus 0, and lastly plus k times 0 minus 0. So this only has an I and j component. The I component is negative 3 over root 10, and the j component is 1 over root 10, and there's no z component, it's 0. And that would be the binormal vector at t equals 0. So there you go. This is how you find the unit normal vector and the binormal vector given a vector. Thank you.